Alright, so this video is going to be part 3 of our sequences and series review, and this video will be on partial sums. Now I'm going to talk a little bit about series, just like introducing that whole idea of a series before we get into partial sums, just because in this whole review series I haven't actually got into series. Alright, so first off, what is a series? Well, now instead of having a just sequence where we have a sub n equal to, let's say, n over 2, and we get a list of terms like 1/2, 2 over 2, 3 over 2, and so on. Now what we're going to have is something that looks like this: the sum as n from n equals 1 to infinity of your a sub n. Okay, and that is going to now equal a sub 1 plus a sub 2 plus a sub 3, and so on, a sub n, and so on. Okay, so now you're going to be adding these terms together. All right, so that's the only difference with a series, is now that you're actually adding these terms together rather than just having a comma separated list. Okay, so now I'm going to kind of get into partial sums. Okay, now a partial sum, okay, is the sum up to a point in a series. Okay, so if I wanted the first partial sum, S1, okay, S sub 1, all that is just a sub 1. But if I wanted the second partial sum, S sub 2, okay, that's a sub 1 plus a sub 2. If I wanted S sub 3, well then that's a sub 1 plus a sub 2 plus a sub 3. So it's the sum up to this many terms. Okay, so if you had S sub n, it would be a sub 1 plus a sub 2 plus a sub 3 ... plus a sub n. Okay, so it would be the sum up to, or it would be the sum of the first n terms, I guess you could say. All right, so what we can do with these partial sums is we can plot them. Okay, so for a sequence, we had a sub n versus n. Okay, and what we did was we just graphed what our a sub n was at a given n. Well, now we can do the same thing, but with your s sub n instead, with your partial sums. So you have s sub n versus n. Okay, and this can tell you whether the series is going to converge or diverge, right? Are all these numbers going to add up to be a finite value, or are all these numbers going to add up to be an infinite value? And this graph of partial sums is going to tell you that. This is not the graph of your individual terms, okay? It's the graph of the partial sum. So all these terms added together. So it's telling you where your sum is going. So if we take the limit as n approaches infinity of s sub n, now we can tell whether this series that we're going to be dealing with is going to be convergent or divergent. And we have the question on the board: what is the sum of the series with the partial sum s sub n equals 5n plus 7 over 10n? Now, as I was talking about before, we take the limit as n approaches infinity of our partial sum, which is now 5n plus 7 over 10n. Okay, this is not our a sub n. Okay, this is not where our terms are going, it's where the sum of our terms is going. Okay, so we can just divide everything by n here, or you can, if you're pretty experienced with limits, you understand the concept, you can look at just the highest power of n, right? So we don't care about this plus 7, that's not going to do anything for us. Look at the highest power of n on the top and the bottom, that happens to be n on both the top and bottom, and you look at the coefficients. Okay, now here we have a 5 and here we have a 10, and 5 divided by 10 is 1/2. So you know that this limit is equal to 1/2, and that is going to be the sum of this of the series that has this partial sum. Okay, so that's the idea. Now what if we were asked the question to express the series from n equals 1 to infinity of 1 over n times n plus 1 as a telescoping sum. Now, first off, we need to remember what a telescoping sum is. Okay, what does this mean? Well, a telescoping sum was basically when we would take this series and we would write out the nth partial sum. Okay, so we'd write out our terms up to n. And, well, let's say that was a 1 minus 2 plus a 2 minus 3 plus a 3 minus 4 and so on. And that would get up to, let's say we had a n minus n plus 1. Okay, so we wrote out our nth partial sum. Now what you see here is this is a telescoping series because it's a telescoping sum because it starts collapsing, okay, like a telescope, like a pirate's telescope, okay? It starts collapsing because this negative 2 cancels out with this positive 2. The negative 3 cancels out with the positive 3. Negative 4 is going to cancel out with the 4 that will come right after this, okay, in the next parentheses over. And this n will get canceled out by the n that comes before it. Okay, there'll be a negative n before it. And what you're left with is that your partial sum, your nth partial sum, is going to equal 1 minus 8 n plus 1. So that's basically how we're expressing this as a telescoping sum. Okay, this is what a telescoping sum means. Okay, you're having a bunch of terms cancel out. Okay, it's collapsing like a pirate's telescope, and you're ending up with something a lot nicer for your nth partial sum. And from that nth partial sum, you can find the actual sum by taking the limit as n approaches infinity. Now for this problem, we have to start off by breaking up this fraction, okay? And if we break up that fraction, we get 1 over n minus 1 over n plus 1. How did I do that? That's a partial fraction decomposition, okay? So once you do that, now this becomes a little easier. So write out the nth partial sum, okay? What would the nth partial sum be? Well, let's start off. Our first term is n equals 1. So we get a 1 over 1 minus a 1 over 1 plus 1. Our second term, plug in 2 for n. We get a 1/2 minus a 1 over 2 plus 1. Third term, we get a 1 over 3 minus a 1 over 3 plus 1. Fourth term will be a 1 over 4 minus a 1 over 4 plus 1. What about the nth term, okay, where this partial sum will end? Well, we'll get a plus, this will be a 1 over n minus 1 over n plus 1, right? Just this. So 1 over n minus 1 over n plus 1. All right, so now that we have that all written out, what we can do is start simplifying here. You see that 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and the hard one here, 4 plus 1, that's 5. Now, the negative 1/2 will cancel out with the 1/2 here. The negative 1/3 will cancel out with the positive 1/3. Negative 1/4 with the positive 1/4. The negative 1/5 will cancel out with the 1/5 that comes immediately after this group here. Why did this 1 over n get canceled out? Well, that is because the positive term is coming second here. Okay, it's always getting canceled out by a negative term that comes before it. Okay, so the negative term is coming first here. But here, you see this 1 didn't get canceled out. Why is that? Well, there was no negative term to come before it. Same thing with this negative 1 over n plus 1. There was no positive term to come after it. That's why these two are the only ones left standing. And that means that our S sub n is going to equal 1 minus 1 over n plus 1. Okay? So we've expressed this as a telescoping sum. If we take the limit as n approaches infinity of our S sub n 1 minus 1 over n plus 1, we get that this is just equal to 1, and that is going to be the sum of this series. Okay? So yeah, that's about it, and that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left.
You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.